Alright, in this video, I'm going to be showing you how to use the discriminant to determine the nature of a quadratic function, or let me say quadratic equation. But before I proceed, please kindly subscribe to this channel, like, share, and comment after this video. So we're going to be looking at a case where a quadratic equation would have two equal roots. And for you to know if a quadratic equation is going to be having two equal roots, you may not need to solve it. You can actually use the discriminant, and the nature of the results will tell you. So the discriminant of a quadratic equation is given by d, which is equal to b squared minus 4ac. But before we use this discriminant, there's a need for us to recall the general quadratic equation is given by ax squared plus bx plus c is equal to 0. What does that imply? It implies that a represents the coefficient of x squared, b represents the coefficient of x, and c is the constant. How do I mean? For instance, if I have something like, say, 3x squared minus 5x plus 2 is equal to 0. So my a basically is 3, my b is minus 5, and c is equal to what? 2. That is just by making comparison. So that is not what I actually want to do here. So now, how do we now determine the nature of the root of a quadratic equation? Number one, if d, which is equal to what? B squared minus 4ac, don't forget that d represents the discriminant, is equal to 0. What this implies is that the quadratic equation is going to be having equal roots or equal solution. So meaning that the value of x of that quadratic equation is going to be the same. So how do we check for this particular kind of a situation? So let's look at an example. So for example, if we are given a quadratic equation of the form, let's say we have x squared, let's say we have x squared minus 4x, right, plus 4 is equal to 0. All I want to do now is I want to show you that this particular quadratic equation will have equal roots. So how do I know if it's going to be having equal root or equal solution? So if I compare with the standard equation that I have here, that is ax squared plus bx plus c is equal to 0. What does that mean? It implies that my a is equal to what? That is a is equal to 1, because the coefficient of x squared here is 1. Then my b, the coefficient of x here is minus 4, and my c is equal to what? 4. So if I plug it into this and it is equal to 0, it implies that this particular equation we have what? Two equal roots. So I may not just need to solve it, I may just give the answer. A question like this can come out in GRE, whereby they will tell you how many roots does this quadratic equation, the nature of the root basically. So if I plug it in here, I have what? D will now be b, that is minus 4 square, that's b square minus 4, then into bracket, what is a? That is 1, into bracket, what is c? C, that is 4. So in that case, minus 4 square is the same thing as minus 4 multiplied by minus 4. Minus times minus plus 4 times 4, that is what? 16. So this will give us 16. Minus 4 times 1 minus 4, minus 4 times 4, that is what? Minus 16. So 16 minus 16 is equal to 0. So d in this case is equal to 0. So what does this imply? It implies that this particular quadratic equation that I solved here is going to be having what? Equal root. Now let's now check the root. If it's going to be equal, I'm talking about if the root will be the same. So what we want to do now is we want to solve this quadratic equation. So let's solve it. I have a space here. So I have what? X squared minus 4x plus 4 is equal to what? 0. So what do I need to do? I can decompose this particular equation. So if I decompose it, what's the coefficient of the first term? That is 1, and the last term is 4. This is how you factor it. So we have 4. We are looking for 2 factors of this 4 such that when you add the 2 factors together, it will give you -4. And when you multiply the 2 factors together, it will give you +4 here. And that will give us what? -2 and what? -2. -2 minus 2 will give me -4. -2 times -2 will give me what? +4. So that implies that wherever I have -4 here, I can replace with what? -2x minus 2x. So I can rewrite this equation like this: x squared minus 2x minus 2x, right, plus 4 is equal to what? 0. So with that understanding, I'm going to be having what? So I can factor this separately and I can factor this separately. And one unique thing is whatever factor I have here will repeat itself here. How do I know? X is here, X is here. I can take X out. Then X will still remain here. X times X is X squared. What can I multiply by X here that will give me -2? That is minus what? 2. So definitely X minus 2 will repeat itself here as X minus 2. So the only thing I'm going to be having outside here will still be what? -2. How do I know? -2 times X minus 2X minus 2 times -2, that's +4. Everything is equal to 0. So X minus 2 is common on both sides, so we take it as a factor. And X minus 2 is also here, so we can have what? X minus 2 into bracket X minus 2 is equal to what? 0. So X minus 2 is equal to 0, and X minus 2 is equal to 0. So X will now be, remember I told you whenever you take a negative number to cross this equality sign, it becomes positive, and if it is positive, it becomes negative. So now with 0 plus 2, and also X is equal to what? 0 plus what? 2. So if we solve further, what we are going to be having is what? X is equal to 2 and what? X is equal to 2. So this validates the proof we did here, that the roots are what? Equal. Equal in this sense means that they are of the same root. So I want to believe somebody has learned one major thing here. So please kindly subscribe to this channel and see you in the next video. Thank you.